Welcome back, students. In this video, we are going to discuss the solutions of exercise 12.3 problems from the chapter Areas Related to Circles. And the topic covered here is areas of combinations of plane figures. So let us begin. Here is the first question. Find the area of the shaded region in the given figure where PQ is equal to 24 cm, PR is equal to 7 cm and O is the center of the circle. Correct? So first, let us list out what and all information we have in the given problem along with the diagram. So given parameters are PQ, that is equal to 24 cm, as well as PR, that is equal to 7 cm. Also, they have given that O is the center of the circle. Now, if you observe the diagram, we have O here and we have a line RQ which is passing through the point O. Therefore, what you can say? You can say that RQ, that is the diameter of the circle. Correct? Now, if you observe the shaded region, that is covered in the semicircle formed by RQ. How you can find the area of the shaded region now? Before going to that, we have to see the triangle here which is inside the semicircle. The triangle PQR. So which type of triangle PQR is? How you can find that? If you observe the angle P here, that is equal to 90 degree. In triangle PQR, angle P is equal to 90 degree. What's the reason? Reason is angle formed on a semicircle. Angle formed on a semicircle. Correct? So now let us see how we can find the area of the shaded region. What's the area of shaded region? Area of shaded region, that is equal to area of the semicircle minus area of the triangle PQR. Yes. So how we can find the area of semicircle as well as area of the triangle PQR? So first, let us go with the area of semicircle. So already you know that the area of circle is pi r square. Area of the circle is pi r square. Therefore, what is the area of semicircle? So area of semicircle is given by pi r square divided by 2. Why it is so? Because semicircle is half of the circle. Therefore, area of semicircle, that is equal to pi r square divided by 2. But if you observe all the given parameters here, we don't have the value of r. So how you can find the value of r now? How you can find the value of r? So if you observe the diagram, r is equal to half of RQ, which is the diameter here, right? Now, if we find RQ, we can find the value of R. So observe, what is RQ here? RQ, which is the side opposite to angle P. That is, the side RQ, which is hypotenuse. And if you observe here the given parameters, we have PQ and PR. So we have given with PQ is equal to 24 cm as well as PR is equal to 7 cm. So by applying the Pythagoras theorem for the triangle PQR, we can find the side RQ, which is hypotenuse of the right angle triangle. Correct? So let us move on with a triangle. So, if we apply the Pythagoras theorem to the right angle triangle PQR, what we get? We have PQR where angle P, that is equal to 90 degree. Therefore, when we apply the Pythagoras theorem, it becomes RQ square, that is equal to RP square plus PQ square, where they have given that RP is equal to 7 centimeter and PQ is equal to 24 centimeter. So let us apply the values here. RP is 7, so it is 7 square plus PQ is equal to 24, therefore it is 24 square, which is equal to 49 plus 24 square is 576. So if we simplify this one, we'll get RQ square, that is equal to 625, and RQ, which is equal to square root of 625, that is equal to 25. What is 25? What is the unit of it? Unit of it is centimeter. Why? Because we have given with the RP as 7 centimeter as well as PQ as 24 centimeter. Now we got RQ is equal to 25 centimeter. Therefore, what is RO or what is OQ? It is radius. Therefore, RO is equal to 25 by 2 centimeter. Okay. So now we have the value of R here. What we can find? Using this R, we can find the area of the semicircle. So what is the area of semicircle? Area of semicircle, that is equal to area of semicircle, which is equal to pi r square divided by 2, or that is equal to 22 divided by 7 into 25 by 2 whole square, because we have r square here, or I can write 25 by 2 whole divided by 2. So when we get simplified, what you will get the answer? We'll get the answer area of semicircle, that is equal to, which is equal to 245.536, and the unit of this is centimeter square. So keep this as equation 1. Now what we have to find? Yes, correct. We have to find the area of the triangle. What is area of triangle? Area of the triangle PQR. So we know that triangle PQR is a right angle triangle. Therefore, area of triangle, that is equal to half into base into height. So observe that we have base into height. Here we have two values, 7 and 24. We can consider anything as a base or anything as a height. Therefore, this is equal to half into 24 into 7. So which is equal to 2 ones are 2 12s are 12 into 7 is 84. So what is 84? It is again centimeter square, and this is the area of triangle PQR. Now what we have to find? We have to find the area of the shaded region. Therefore, area of shaded region is equal to area of the semicircle minus area of triangle PQR. So when we substitute the values, whatever we got, area of semicircle is 245.536 centimeter square. 245.536 minus 84, which is the area of triangle PQR. So when we simplify this one, what answer you will get? You will get the answer 245.536 minus 84, which is equal to 161.536. 161.536, and the unit is centimeter square. This is the area of this shaded region. So observe that units are very important in this kind of problems. Fine. We'll move on to the next. Here is the second question. Find the area of shaded region in the given figure if radii of the two concentric circles with center O are 7 cm and 14 cm respectively, and angle AOC is 40 degree. So let us list out the given parameters here. So before that, let us see what they have given in the question. Here we have two concentric circles. So what do you mean by concentric circles? Yes, you are correct. The concentric circles are nothing but the circles having the same center. So here in this diagram, I can consider the smaller circle as circle 1 and the bigger circle as circle 2. Also, they have given the radius as 7 cm and 14 cm. Therefore, I can take 7 cm for the circle 1, that is R1, as well as 14 cm for R2, that is the second circle. Now, the question is to find the area of shaded region. So, what is the shaded region here? If you observe, the area OACO, that is nothing but area of the sector of circle 2, right? As well as we have the area of the sector for circle 1. Now, both the sectors are having the central angle as 40 degree. That is, theta is equal to 40 degree here. So, how we can get the area of the shaded region? Area of shaded region, that is equal to area of the shaded region, which is equal to area of the sector 2 minus area of sector 1. Now, how you can find the area of the sector? What formula you are going to use? If you remember, you had learnt area of sector, that is equal to theta by 360 into pi r square. Correct? Now, we can use the same formula to find the area of sector 2 as well as sector 1 with the difference of r as 7 cm for the sector 1 and r is equal to 14 cm for sector 2. Now, let us find one by one. Area of sector 2, which is equal to theta by 360 into pi r square, which is equal to theta here is 40 degree divided by 360 into 22 by 7 into r here is 14, so I can write 14 into 14. When I cancel this one, we can cancel 0 and 0. 4 ones are 4, 9s are also 7 ones are 7, 2s are. So if we continue with this one, I will get the answer here as 22 into 2 into 14 divided by 9. So when we multiply, I will get here 616 divided by 9 centimeter square, because the unit here for the radius is centimeter, right? Now we'll find the area of the sector 1. We got area of sector 2, that is equal to 616 divided by 9 centimeter square. Let us find the area of the sector 1, which is equal to theta by 360 degree into pi r square, where r is equal to 7 centimeter for sector 1. 40 degree divided by 360 degree into 22 by 7 into r is 7. So 7 into 7, because we have r square here. When we cancel, we'll get 4 ones are 4 nines are 7 ones are 7 ones are. So remaining is 22 into 7 divided by 9. Therefore, area of the sector 1, which is equal to 514, it is 154 divided by 9, that is 154 by 9 centimeter square. What we had asked to find the area of shaded region, correct? So what is the area of the shaded region? Area of shaded region, that is equal to area of sector 2 minus area of sector 1. So we can write area of sector 2 is 616 divided by 9 minus area of sector 1 is 154 by 9. That is equal to, in the denominator it is 9. When we subtract 616 and 154, what answer you will get? You will get the answer as 462 divided by 9. So let us see if we can cancel this one. 3 3s are 9, 3 1s are 3 15, 3 5s are then 12, 3 4s are. Therefore, the answer is 154 divided by 3 centimeter square, and the answer is area of shaded region, that is equal to 154 by 3 centimeter square. Hope you all got this answer. Let us move on to the next problem. Here is problem 3. Find the area of the shaded region in the given figure. If ABCD is a square of side 14 cm and APD, here we have A, P, D and B, P, C are the semicircles. Correct? Now let us see what they have given with. They have given that ABCD is a square. So what are the properties of the square? Square is nothing but all the sides are equal. That is AB is equal to BC is equal to CD, that is equal to DA, which is equal to 14 centimeter. Also, what they are saying? A, P, D and B, P, C are semicircles. Correct? Now, if you observe, we have to find the area of the shaded region here. By looking at the diagram itself, we can understand that the shaded region is the leftover part of the square when we subtract the area of these semicircles. Correct? So, how you can find the area of shaded region here? Area of shaded region, that is equal to area of the square minus 2 into area of semicircle, or you can write that area of the square minus area of the circle. And what is the radius you are going to consider for the circle? They have given that the side is equal to 14 centimeter. Correct? So this is 14 centimeter. And they also said that AD is the diameter of the circle by giving it as semicircles. Therefore, what is the radius here? Radius R is equal to 14 divided by 2, which is equal to 7 centimeter. Now let us find the area of square as well as area of the circle. Why I am writing here area of the circle? Because here we have the semicircle APD as well as we have the semicircle BPC. So when we add them, it becomes the complete circle with radius 7 centimeter. Now let us go with one by one. What is area of the square? Area of the square, that is equal to A square, or you can take it as the side square. So what is the side given? We have given with 14 and the area of the square, that is equal to 14 square. What is the square of 14? Which is equal to 196 centimeter square. Correct? Now let us find the area of the circle. What is the area of the circle formula? Area of circle, that is equal to pi r square. So observe that they have not asked to take pi as any value. So here you can just substitute pi as 22 by 7 into what is the value of r here? As I already said, r value is 7. So we have here r square, therefore it is 7 into 7. And when we simplify this, what we'll get? 7 and 7 gets cancelled, and when we multiply 22 into 7, what we get? It is 154 centimeter square. Observe that we have the area of the square as 196 and area of the circle as 154. Therefore, what is the area of the shaded region? Correct. So, area of shaded region, that is equal to area of the shaded region, which is equal to area of square minus area of the circle. So what are the answers we got for area of square and area of circle? Which is equal to 196 minus 154, and the answer here is 42 centimeter square, and this is the area of shaded region. Hope all of you understood with this problem. Let us move on to the next problem. Here is the fourth question. We have to find the area of the shaded region in the given figure, where we have circular arc of radius 6 cm and it is drawn with a vertex O of an equilateral triangle, and it has a side 12 centimeters from the center. Right? So here, how we can solve this problem? If you observe the diagram, we have a circle here as well as we have a triangle, and we have to find the area of both of them to get the area of the shaded region. But one thing you have to be careful here, because we have a sector here. If you can observe the shaded region in the red color. So this is the area which is covered by both the triangle and the circle, right? So how you can find the area of the shaded region? In the question, we can find the area of the shaded region by taking the sum of area of the circle and area of the triangle, and then by subtracting the area of the sector, that is area of shaded region, that is equal to area of circle plus area of triangle minus area of the sector. Now here how we can find the answer? We can go with one by one and find the areas separately, then we can combine them accordingly. So here the first we have to find the area of the circle. So what is the area of the circle? Area of the circle, that is equal to pi r square. So since they have not asked us to take pi value as anything, we can just go with 22 by 7 into r square. R here is 6. So I can take 6 into 6. Therefore, when I multiply, I will get 22 into 36 divided by 7. So what is the answer here? Area of the circle, that is equal to yes. What's the area of the circle here? It is 792 divided by 7 and the unit is centimeter square, right? Now what we have to find next? We have to find the area of the triangle. What's the formula to calculate the area of triangle? So area of triangle, since it is equilateral triangle, we can use the formula root 3 by 4 into side square, that is equal to root 3 divided by 4 into side here is 12. Therefore, I can take 12 into 12. So this becomes 4 ones are 4 threes are, that is equal to 12 into 3 into root 3. So which is equal to 36 root 3 centimeter square. Now we have found the area of the circle as well as area of the triangle. Remaining is area of the sector. So let us just list out the values in the next page. We have got the area of circle as area of circle is equal to 792 divided by 7 centimeter square, as well as area of triangle, which is equal to 36 root 3 centimeter square. Now what we have to find? We have to find the area of the sector. So area of sector, that is equal to theta by 360 into pi r square. Now if you observe, theta is equal to how many degree? Here observe that we have an equilateral triangle and it is there at the center O. Therefore, theta is how much? Theta is equal to 60 degree, because we all know that equilateral triangle will have all the angles is equal to 60 degree. Here 60 degree divided by 360 degree into, we can use just 22 by 7 for pi into r square, that is 6 into 6. So here what the answer we will get, 6 ones are 6 6 are 6 and 6 gets cancelled, and the answer is 132 by 7 centimeter square. So how we can simplify this one? Therefore, area of shaded region which is equal to area of the circle, that is 792 divided by 7 plus area of the triangle, that is 36 root 3 minus area of the sector, which is 132 by 7 centimeter square. So when we simplify, what answer we will get here? We'll get 792 plus 252 root 3 divided by 7 minus 132 divided by 7. So I'll just continue this here. So what's the answer? 792 minus 132 minus plus 252 root 3 divided by 7. So when we subtract, what's the final answer we'll get here? What's the final answer we are going to get here? Subtract this one. So what we'll get here? 660 plus 252 root 3 divided by 7, and it is centimeter square because we have the area to find. So the answer is 660 plus 252 root 3 by 7, or you can also write this one as 660 by 7 plus 36 root 3 centimeter square. Understood why? Because here if I separate it, I can write 660 by 7 plus 252 by 7 root 3, right? So 7 and 252 can be cancelled. 7 ones are 7, 36 are. Correct? So the answer is either this or this one. Both the answers are correct here. Let us move on to the fifth question. The question here is, we have to find the area of the shaded region. Let us see what they have given. From each corner of the square of side 4 centimeter. So side, that is AB, which is equal to 4 centimeter. Similarly, BC is equal to 4 centimeter. CD is equal to 4 centimeter, as well as EAD is equal to 4 centimeter. A coordinate of the circle of radius 1 centimeter. It means what? Here we have the coordinates 1, 2, 3 and 4. What is the radius of this? Radius of this is 1 centimeter, which is same for all 4 coordinates. Is cut, and also a circle of diameter 2 centimeter is cut as shown in the figure. So here the diameter is 2 centimeter. So this implies that what's the radius? Radius is equal to 1 centimeter. Find the area of the remaining portion of the square. So observe here that we have cut the diameter here, as well as we have cut the radius 1 centimeter here, in the sense the coordinates with the radius 1 centimeter here. We have 4 corners. It means what? Correct. So it means we have cut 2 circles of diameter 2 centimeter from the square. So what is the area of shaded region here? how we can find the area of shaded region? You're correct. Area of shaded region which is equal to area of the square minus, see here, instead of taking four corners separately, we can combine it and we can make it as one circle with a radius 1 centimeter. Correct? Also, we have another circle here with the radius 1 centimeter. Therefore, we can write area of square minus 2 into area of the circle with r is equal to 1 centimeter. Hope you understood this concept here. Right? Now, let us see how we can find the answer. First, what is the area of the square? Area of square which is equal to side into side, that is 4 into 4, which is equal to 16 centimeter square. Now, what's the area of the circle? Area of the circle is area of the circle that is equal to pi r square. So here, if you observe, they have not asked us to take pi as anything, so you can keep pi as 22 by 7 into, what's the value of r here? It is 1. So we can just multiply by 1 into 1, or the answer remains as 22 by 7 centimeter square. Now we have to find the area of the shaded region. So what is the area of shaded region? Area of shaded region is equal to area of shaded region, that is equal to area of the square minus 2 into area of the circle. So what's the area of the square we got? We got it as 60 centimeter square minus 2 into, what's the area of the circle? It is 22 by 7. Therefore, the answer we will get 16 minus 44 by 7, or this is equal to 7 into 16 minus 44. What's the answer here? 112 minus 44 by 7. So the answer is 68 by 7 centimeter square, and this is the area of shaded region. Hope all of you clear with this question. We'll move on to the 6th question. What we have given here? We have given that in a circular table, we have a cover of radius 32 centimeter. Remember, the radius is 32 centimeter. A design is formed by leaving an equilateral triangle ABC in the middle as shown in the figure. Find the area of the design, or we have to find the area of this shaded region. What they have said, ABC is an equilateral triangle. Therefore, what is angle A, angle B and angle C? That is equal to 60 degree. Also, they said that the radius is 32 centimeter. So, how you can mark the radius here? If I take this as O, I can mark the radius as BO, that is equal to 32 centimeter. Now, how we can find the answer here? What's the area of shaded region? So, area of shaded region, that is equal to area of the circle minus the area of the equilateral triangle. So area of circle minus area of triangle ABC. Now observe how we can find the area of the circle. What's the formula? Area of the circle, that is equal to pi r square, which we can find directly. So area of circle, that is equal to pi r square, and here they have not asked us to use pi as any value, so we can keep it as 22/7 into 32 into 32. Correct? So what's the answer here? When we multiply, we'll get 22,528 divided by 7 centimeter square. Now remember this answer because we have to find the area of the triangle. Now if you remember, you know that what's the area of equilateral triangle? Area of equilateral triangle can be given by root 3/4 side square. Correct? But here we don't have the value of the sides. Also, we don't have perimeter to use Heron's formula. How we can continue with this problem now? So here, observe that we have an equilateral triangle, right? What we can do, let us draw the perpendiculars from the point A, B and C. It becomes like this. Therefore, here I have a center point, that is O. Now, observe the triangle O, B and C. If you observe this one, what is the angle here? At the point D, if I draw the perpendicular like this, I have D here, I have C here. What is the angle D? That is equal to 90 degree. As well as, what is the angle B? Angle B is equal to 30 degree because BO divides the complete angle B into two equal halves. Therefore, angle B is 30 degree. So, how we can find the area of the triangle? We have three equal triangles here, that is A, O, B. Now, BOC as well as AOC. So, area of triangle ABC, that is equal to area of triangle AOB plus area of triangle BOC plus area of triangle AOC. Correct? So if we find any one triangle area, that is enough to find the area of complete triangle ABC. So let us now see how we can find the answer here. So we have the triangle BDO. I'll rewrite the diagram here. We have BOC as well as when I join this and draw the perpendicular here, I'll get D. So what is the area of this particular triangle? You can write it as half into base into height. So we don't know what is base. The base is BC here as well as the height is OD. Correct? As I said you earlier, the angle B here is 30 degree and angle D is 90 degree. So when we have like this, what formula we can use or what concept we can use here? Also, we know that OB, that is radius of the circle, which is equal to 32 centimeter. This is equal to 32 centimeter, right? Now, observe here that we can use sine of angle theta as well as cos of angle theta to find the value of BD and OD. So let us apply that. We have sine theta. What is sine theta? Sine theta is equal to opposite by hypotenuse. So with respect to angle theta, opposite is OD divided by hypotenuse is 32 here, right? So this implies that sine of 30 degree, which is equal to OD divided by 32. So what is sine of 30 degree? Sine of 30 degree is half, which is equal to OD by 32. This implies OD, which is equal to 32 by 2, that is equal to 16, and OD, which is equal to 16 centimeter. Now, how we can find BD? BD is adjacent to angle 30 degree. Therefore, how we can find it? By cos theta. So, what is cos theta? Cos theta is equal to adjacent BD divided by hypotenuse 32. So, this implies that cos of 30 degree, which is equal to BD by 32. What is cos 30? Cos 30 is root 3 by 2. That is equal to BD by 32. Or this implies that BD, that is equal to 32 into root 3 divided by 2. So this gives you 16 root 3. What is 16 root 3? It is centimeter. So I am getting BD as 16 root 3. So if you observe here, D is the midpoint of BC. Therefore, what is DC? DC is also 16 root 3. Now we can find the area of triangle OBC. Now what is the area of triangle OBC? We have area of triangle OBC, that is equal to half into base into height. So half into, what's the value of base? Base is equal to 32 root 3. Why? Because we have 16 root 3 plus 16 root 3. That gives you 32 root 3 into height, that is OD. So here OD we got as 16 centimeter. So if we simplify this one, what we'll get? We'll get 2 1s are 2 8s are 16, and when we multiply we'll get 256 into root 3 centimeter square, which is the area of one triangle OBC. Similarly, we have triangle OBA and triangle OCA. So, areas of both these triangles are equal to 256 root 3 as well as 256 root 3. Now, what we have asked? We have asked to find the area of the shaded region. So, area of shaded region, that is equal to area of shaded region, which is equal to area of circle minus area of the triangle. What is the area of the triangle? That is 256 root 3 into 3. So this gives us 768 root 3 centimeter square. This is the area of triangle, correct? Now, what we have as the area of circle? Area of circle, that is equal to 22,528 divided by 7 minus area of triangle is 768 root 3. Therefore, what's the answer? We can write the answer as 22,528 divided by 7 minus 768 root 3 centimeter square. So here, no need to simplify. We can keep the answer as it is. We'll move on to the next. So here is the 7th question. We have a given figure. In that, we have ABCD as a square with side 14 cm. Also, with centers ABCD, we have drawn 4 circles in such a way that each circle touch externally 2 circles out of remaining 3 circles. Find the area of shaded region. So if you observe the diagram, we have a square ABCD and the circles 1, 2, 3, 4 are drawn by having the centers as ABCD respectively. Now, if you observe the diagram, circle 1 is touching the circle 2 as well as 4 at the points on the side of the square. If I have to name it, I can name it as P here, Q, R and S. Correct? So we have to find the area of shaded region. Here we have given with the side of the square as 14 cm. So what we can write? We can write here that AB is equal to BC, that is equal to CD, which is equal to DA, that is equal to 14 cm. Correct? And we have drawn the circles by taking the vertex of the square. So here, what is the radius of the circle? What's the radius of the circle here? Radius of the circle is half of the side of the square. Why? Because here, if you observe, radius are touching each other on the square, right? Therefore, this becomes half of the side. Yes. Now, what's the radius of the circle? That is equal to 7 cm. How we can find the area of the shaded region here? Area of the shaded region is the remaining part of the square after taking out the coordinates 1, 2, 3 and 4. So what we can do here? We can take the area of the square and we can subtract the area of one complete circle with a side 7 cm. Why? Because with a radius 7 cm. Why? Because if you observe, when we add coordinate 1, 2, 3 and 4, we'll get one complete circle of radius 7 cm. Correct? Therefore, area of shaded region, which is equal to area of shaded region, that is equal to area of square minus area of the circle. How you can find the area of the square? Area of the square is equal to this side square, that is A square, which is equal to, what is the side over here? Side is 14, therefore 14 square, which is equal to 196 and the unit is centimeter square. And what's the area of the circle? Area of the circle is given by area of the circle, that is equal to pi r square. So here they have not asked us to take pi as any value, so we can keep pi as 22 by 7 into, what's the r value here? As I already said, r value is 7. So this becomes 7 into 7. 7 ones are 7 ones are, remaining is 22 into 7. So this becomes 154 centimeter square. Correct? Now, what's the area of shaded region then? Therefore, area of shaded region is equal to area of shaded region, that is equal to area of the square, which is 196 here, minus area of the circle, that is 154, which is equal to 42 centimeter square. And this is the answer for the question asked. Let us move on to the next question. Here is the 8th question. A racing track whose left and right ends are semicircular. The distance between the two inner parallel line segments is equal to 60 meter and they are each of 100 meter long. So observe here that in the diagram the left and right ends are semicircular. It means what? Here the internal circle, this is the semicircle, as well as here is the semicircle. It means what? We have a inner circle as well as we have the outer circle, that is here semicircle on the left hand side as well as semicircle on the right hand side. That means we have a outer circle, right? Also, they have given that the length between or the distance between two parallel lines EF and HG. They have given that inner parallel lines, so we have to take EF and HG, that is 60 meters. So if you observe, we are having the inner semicircle on both the ends. Therefore, what is the diameter of the inner circle? Diameter of the inner circle is equal to 60 meter. This implies that R is equal to 30 meter. Okay. Now, what else they have given? They have also given that the length of the inner edges or the length of EF and HG, that is equal to 106 meter. So this is 106 meter here. Correct? Yes. Now, what else they have given? They have given that the track is 10 meter wide. That is the width of the track, that is 10 meter. So using this one, we can write the diameter as well as radius of the outer circle. So what is the diameter? Diameter is equal to the diameter of inner circle, that is 60, plus width of the track, that is 10 here on the top and 10 in the bottom. So it becomes 10 plus 10, that is equal to 80 meters. So 80 meters is the diameter of the outer circle. Therefore, radius of outer circle, that is equal to 80 by 2, which is equal to 40 meters. Correct? Let us see what is the question asked. The question asked here is the distance around the track along its inner edge. So what you have to find? You have to find the perimeter here using the inner edge, right? So we have to consider the circle here, semicircle on the left hand side, semicircle on the right hand side, as well as the length of EF and HG. Or we can also say that the complete inner circle, perimeter of the complete inner circle plus the length of EF and HG. So let us see the first question. The first question is length of inner edge, which is equal to the perimeter of the inner circle, perimeter of the inner circle plus the length EF plus the length HG, which is equal to, what's the perimeter of the circle? That is 2 pi r plus what is the length EF, which is already given that 106 meter, even HG is 106 meter. So 106 plus 106. Now we have not asked anything to take for pi, so we can keep it as 22 by 7 into, what's the radius of the circle here? Radius of the inner circle is 30 meters. So 30 plus 212, that is 106 plus 106, which is equal to, when we multiply, we'll get here 44 into 30 by 7 plus 212, which is equal to 1320 by 7 plus 212. Check if you can cancel them. We'll not be able to cancel this one, so we can keep the answer as it is. They're asking for the length of the inner edge, so we can keep it as meters here, because all the units here are in meters. Correct? So now, what's the second question given? The second question here is to find the area of the track. Area of the track. What's the track given? Track is something like this, right? So here we can write this one. How we can find the area of the track here? If you observe, we have a rectangles here, this area 1 and the second rectangle which is having the same area as well as area of this. Correct? So how we can find this one? We can find the area of rectangles, or we can find area of one rectangle and we can multiply it by 2, so that we'll get the area of this part and this part. Now we have the semicircles. So if we combine that, how we'll get? We'll get it like this. Correct? We have to find the area of this region. So how you can find the area of this region? We can find it by area of the outer circle minus area of the inner circle. Correct? So how you can find the answer now? What's the area of rectangle? Area of rectangle is length into breadth. Area of rectangle, that is equal to length into breadth. What's the length? Length is 106 meters and breadth, or we can just take it as width, that is 10 meters. So the answer is 1060 meters. Therefore, we have two rectangles here. What's the total area of those rectangles? So total area of two rectangles, that is equal to 2120. Correct? 1060 into 2. That is equal to, it is area, so we have to write it as meter square. Now we have to find the area of the circle here. What's the area of the smaller circle? Area of the inner circle, that is equal to pi r square. So pi we can take it as 22 by 7 and r for the first circle is 30 meters. So 30 into 30. This becomes how much? Divided by 7. Correct? Now, what's the area of outer circle? Area of outer circle, that is equal to same pi r square, but what we have to do here, we have to take r is equal to 40 meters, right? So what's the area of outer circle? Area of outer circle, that is equal to 22 by 7 into 40 into 40. This gives us 22 into 1600 divided by 7, or the answer for area of outer circle is equal to 22 into 1600. It gives us 3200,00253. So it is 35,200 divided by 7. Correct? Now let us find the area of the circle. So area of circle, area of the circular track, whatever we have here, I'll just name it as area of the circle, that is equal to 35,200 by 7 minus 19,800 by 7. So which is equal to 7 remains in the denominator and numerator becomes 35,200 minus this one. So we'll get here 5 and here 1. So I'm getting here 15,400 divided by 7, and this is the area of the circle. So what we have to find? We have to find the area of the track. So finally, therefore, the area of the track, that is equal to 2,120 plus 15,400 divided by 7. Since it is the area, we can write the unit as meter square. Therefore, area of the track, that is equal to 15,400 divided by 7 plus 2120. Here we can cancel 7 ones are 7 twos are 14, again 1, 7 twos are 14, 2,200. So if we add them up, what's the answer we are getting? We are getting 43,020 and the unit is meter square. Hope all of you understood the problems till 8th. So keep watching, continue learning. Let us meet in the next class with the exercise 12.3 part 2. Thank you.